Hi, everyone. So today's lecture is going to be um, recorded because due to recent changes in YÖK rules, things are still a little bit uncertain whether we can do this online or physically offline. And I also wanted a recorded version of today's lecture to be with you in case you have to return back to it. Now, last week we did some work with Twitter API, and as many of you know, some of you managed to do this. Some of you managed to get an authentication through login. Some of you couldn't. This is very normal with regard to APIs, and especially popular APIs. So, since Elon Musk took over Twitter, there has been a lot of changes to access rules, data pull requests, and changes to the application programming interface, or API, has been one of them. So what this means for us is that up until very recently, recent policy changes in Twitter, we were able to get data from Twitter relatively in a straightforward way. We would authenticate using our login credentials. And through our browser, we would be able to get data access. Or we would pay money and get API keys. So API keys are kind of like passwords that belong to you only and refer to a specific data access rule. So if you are, for example, an enterprise client or a big company, you would be able to pay a lot of money, but also get a lot of data as well. If you were just a researcher, you would either get free API or at least pay a very little amount of money and get low level of API data access. Now, these are all changing now. And changing API rules are a standard part of what we do. In computational social science, we always have to be very aware of data access rules and changes to data permissions. So in technical term, that is called an API policy change. So before explaining what an API policy change is, I would like to show you a little video on what an API is so that you understand better what is the access protocol that we're using in order to get data from Twitter. Yeah. So what happens when the waiter is no longer working? Or what happens if you can't really ask everything from the waiter, and what you can and cannot ask from that waiter changes? So API is one way of getting data from the internet. It is a softer approach. An API is maintained by the platform from which you are trying to get data from. In this case, Twitter API is maintained by Twitter. And when there are policy changes to that API, it affects how much data you can get, how frequent you can get, and whether you can get data or not. Now, in the direct opposite of API data is what we call scraping, web scraping or social media scraping. Now, scraping is what we are going to do today. It is another way of getting data from the internet. So let's see what web scraping is. Of course, in order to understand which web scraper to use, first you have to build your first web scraper yourself. Some people rely on services and products that do these scraping functions. But in order to know which one is better, which one is not, better, you first have to understand the basics of scraping and how essentially it works. And today, what we're going to do is that we're going to do some basic web scraping. So today, we are going to start with scraping the simplest of sites. And that website is Wikipedia. Wikipedia, due to its page structure, is one of the easiest websites to learn how to scrape. In order, you can basically get really valuable quantities of data from Wikipedia. So today, as an exercise, we're going to build some temperature data from Phoenix, Arizona. And when we look at this website, we are interested in Arizona's temperature. So high temperature, low temperature. And we want to create a climate chart like this, a chart that shows the high temperatures and low temperatures. Now, in order to do this, we need this particular table. We are going to build a visualization that takes into account the record high, mean maximum, average high, average low, and mean minimum. So in order to be able to do this, what I have to do is that I need to scrape this individual table. Now, for those of you that are new to scraping, we explain any program, Python or R or Java, doesn't matter, through the browser by using HTML tools. Now, when you right-click on this page, you're going to notice that there is an inspect button here. Once you click on the inspect button, it is going to give you the background of this web page, the HTML codes of everything that is happening in this website. So where individual links are, where individual tables are. So here is the code structure of this entire website. So if you, for example, want to scrape a paragraph like this, you have to basically scrape through here. So every single line here represents a section of the website. And as far as this table is concerned, there are two lines that correspond to this. So div and div. This gives us the direct link to this individual table. So one way of scraping websites is to copy their actual path, basically how they appear on an interface, and copy that and introduce that to your R session or Python session. Today, we are going to do one of the most basic forms of scraping, and I'm going to explain to you how. So I'm going to open a new window, and we are learning scraping this week because last week we didn't have that much chance with the API. Some people could get data from the API, some people couldn't. When APIs work, they're very useful and they're very easy to work with, but sometimes APIs get into troubles themselves. And that is why you should always learn how to scrape data from a web page directly without relying on an API. Just a small note, API is a safe way of getting data from the internet, whereas scraping is a very unsafe way of getting data. It's basically forcing that website's bandwidth in order to extract data. And some websites ban scraping altogether because it's not a wanted thing. But if you're basically doing a very simple and small operation, then it is usually fine. So how do we scrape data, extract data from a web page on R? We use a package called rvest. So with my computer, library already contains rvest. For those of you who do not have rvest, you can do install packages rvest. The same goes for other library items that I'm listing here. In case you haven't installed them, first install them. So I am really, let me change the global options so that my appearance becomes a little bit more visible to you all. Let me pick something more visible here. Maybe this, yes. So rvest is a scraping package. So the second package you need to load will be what we call data table. Data table package makes it easier to change data frame structure. So you might remember 2 weeks ago, we converted a data from long form to wide format and wide format to long format. Data table makes it easier to do these things. So we need to add library data table as well. Then we need the dplayer package. Dplayer is used for data manipulation. So library dplayer. And we need ggplot for visualization, library ggplot to and of course, instead of doing all of these packages one by one, you can retain rvest and this data table, dplayer, ggplot, and all of those are all listed under the tidyverse package instead of loading all of them together. You can download tidyverse, includes dplayer data table. It includes the piping function, Magit TR. It includes ggplot. So everything is actually in the tidyverse. So first thing I'm going to do is that I'm going to introduce rvest to the session. Then I'm going to introduce tidyverse to the session. So first thing we do in scraping is that we introduce the URL from which we are scraping to the session. And to do that, we are going to create a new object called URL. Oh, I need to change this to English. So the URL is going to include the link of this web page. In this context, it's enwikipedia.org, Wiki Phoenix, Arizona. I'm going to copy that. And I'm going to paste this in between two quotation marks. And when I do run, it is going to introduce our specific URL to our session. Now, from this web page, what do we need? We need this table. We need this table, and we are going to require the record high row, which is basically this row, And we are going to require the record low so that we are going to produce a graph that is similar to this one here. So I only need two data from here. I need record high data, and I need the record low data. So in order to specify those, I need to create a new object called kept columns. I'm saying kept columns because I'm not going to keep the rest of these columns. I'm going to discard them. And I need to create a vector, which is going to include first record high in Fahrenheit and Celsius. So I have to copy and paste this here. Record high Fahrenheit and Celsius. And then another range, which is going to include record low. I'm going to copy this as well so that I don't make a mistake. So I need two columns, record high and record low, both of them specifically as they're written in this web page and listed as a vector. So when I click on this, it contains a new value called kept columns, which includes the record high values and the record low values. Now, we already mentioned the URL here. This is our new object. So in order to read the page, we need to create a new object called the web page. And that is going to read the HTML. It's a function that comes from tidyverse. It is going to read our URL. It is basically going to read, using rvest, the entire Wikipedia page for Phoenix, Arizona. So now we have scraped essentially the web page using rvest, using the function called read HTML. When we look at it, it says this has a head, a body, XML attributes. So it has already downloaded the website into my R. Now, from this web page, I need the XML attributes. I need to take the table data from this web page. So I'm going to create a new object called tables, or TBLS. What that's going to do is that it is going to extract the HTML nodes from my web page, and it is going to contain only the section that has a table. So what I'm asking this is to go inspect this web page, and from the page in which you contain, where you can see a table, take this table and read it using its nodes into a new object called tables. So I'm going to run this as well. So it has a new tables form with a list of 25 values in that web page. Now, when I just write tables here and run it, it is going to include all of the HTML variables of my table, which is right here. Now, what's going to happen here is that only one table should be returned. If more tables are discovered in this web page, we have to introduce a criteria. We are going to say that, there are multiple tables in this page. Give me only the table that starts with the term climate data and drop others. How I'm going to do this is as such. I am going to format the tables data here, and I'm using the edged brackets. I will ask R to use the grep function, pattern matching and replacement. It asks a function to look for specifically the criteria that I'm going to enter. And I am going to use climate data, the specific, because these tables do not have a table number. I can't say that give me table 2.1 or give me table 5.8. I need some kind of criteria, and I need the table, this table, that contains climate data in its title. So as a string value, I am going to copy climate data here. And when doing this, get the tables that conform to this criteria. And I want this to ignore case. I don't want this to contain any lowercase or uppercase criteria. So I'm going to say true to here. So I'm doing run, and soon after I am going to say create a new data frame which contains HTML table, contains tables, but of course, since I didn't wrap this into an actual command, as you can see, my R got stuck. What I have to do is that I just need to stop this command by using Control-C. This has to be wrapped into a data frame. So what I need to do with this code is that I need to wrap this in HTML table, then tables, then grep, then climate data, then tables, ignore case, T. At the end of this, I need to get the fill value, which has to be true, then close parenthesis, and it has to be the first line in this. So when I run this, it should now bring me data frame with 15 observations and 14 variables. Now I'm now able to pull the scraped data and format it into a version that I can use with R. Now, what we did is that we used the HTML code in order to specify this table. And from that table, we extracted the table that contains climate data, and we introduced this into our R session quite successfully. Now, in order to be able to visualize this, what has to happen is that I need to change the names of the data frame, and I have to set the first column of this data frame to change into the function called measurement. So I'm selecting the first row of these data frames, and I need to change them into measurement. So I'm first going to run this. Then I am going to adjust names of data frame of the first row and rename it as measurements. Now let's check this again. Yes, now we all have the measurements related to this individual. So January, February, March, we don't have these extensive long terms. Then we have to convert this into a long format. So we have to change the data frame again. So in this, we have to take the data frame, use the pipe function, and in order to change this into the long format, I need to use the data table command called melt, and melt the identification of the variables that correspond. Sorry, oh, where is my equal sign? Oh. Do I have any equal sign? Let me copy paste this because I can't find my equal sign. Equals vector of measurement, then another pipe function, and we need to filter this measurement data in our data frame in kept columns. So I need to change this wide format data into long format data using the variable called measurement. And this has to be kept within my kept columns data. So when I run this, you're going to notice that our data frame is going to change. And when I click on this again, you're going to notice that it is now in long format. It is more conducive for the type of graph that I'm going to do. So record high, the Fahrenheit values, Celsius values, record low, Fahrenheit values, Celsius values, and the variable is January, February, March, basically according to date. Now, let's get rid of Celsius values and just use this via Fahrenheit values only. So how we do this is that we have to change the values of the data frame because we're going to change Celsius and Fahrenheit values. So data frame change values into, there's a function called gsub, which replaces everything. And in this context, what I'm going to do gsub on is that we are removing extra data includes in the tables that contain Celsius sign. We are trimming the white space and replacing the long hyphen with the short hyphen, because hyphen issue affects casting the character to be numeric. So here we need, these are all long hyphens. We need to connect them to short hyphens because the R cannot right now interpret them as actual numerical values. So this can be a little complex because what we are doing is essentially we are changing individual characters, and that is done in the following formats. So I made a mistake with the previous run several times, so I just wrote the correct code so that you can just copy the correct code as it is. This basically replaces every single dot, slash, hyphen, and everything. It actually deletes everything with basically nothing. So this is just a quotation mark and a quotation mark, and there is nothing in between. So you are basically replacing everything that it sees in the database as this. You're replacing with nothing. So you're basically deleting. This is a delete command. But since we're applying delete command to multiple characters, we have to use the substitute gsub function in order. So when it sees hyphen, double hyphen, parenthesis, dot, asterisk, or other functions, it is going to replace this with just nothing, emptiness, in data frame values. So first I have to run this code. Then I also have to do the same issue in the measurement section. So I already did this with the value section. As you can see now, the Celsius is gone. I need to do the same thing with the measurement section. So I'm selecting this line, and then I am once again. So as you can see, it also got rid of extra parentheses in and any other things that exists in parentheses. So I'm simplifying and cleaning the data as much as I can. Then I need to replace the long hyphen with the small hyphen. So because when we use long hyphen, it is going to misunderstand this as unfortunately not data. So we have to do this as well. Then in order to finalize that all of these characters are numeric, we have to change the value section in the data frame as numeric as character. So now it's going to consider and take everything as a numeric value. Now, finally, we are going to use ggplot to visualize this. So let's create a new object called data viz or data visualization. It is going to take the command of ggplot, and what we are going to visualize is this data frame. So we are going to visualize this. We're going to visualize data frame, the aesthetic function. So X and Y columns are going to be variable and value, the X and Y axes. So it is going to be variable, and then the Y axis is going to be the value. We are continuing with the plus sign. Then we have to do geom line for this. Again, we have to specify the aesthetic function here because now it's going to ask us where would these line values take their values from. As with above, the x-axis is the variable, the y-axis is the value. I'm adding plus and continuing, and I need to add some points at the end of these lines. So I'm going to do geom point, and it is going to take its aesthetic value as color, and it is going to come from measurement. So the low point of this line graph is going to be the record low. The high point of this line graph is going to be the record high. So color is going to be measurement. Then it is size, can be something like, what's the font size? It can be 5. You can change this if you like. So the first part of the data viz is as follows. And then I'm going to increase the values of this data viz once again. I am going to modify data viz into its own object. So I'm going to take data viz, I'm going to use a theme. 538 is a nice theme. You can explore with other themes as well. You can look at The Economist, you can look at any other values if you like. You can explore. Then I need to do some trimming of the y-axis. So scale y continuous. I need to add breaks here into a sequence of, let's start from -60 Fahrenheit, and let's say it should go all the way to 150 with the intervals of 10 degrees Fahrenheit. Then we are going to add labels. The title would be something like Phoenix temperatures yearly. And the subtitle can be our URL. So Wikipedia, Wiki, Phoenix, Arizona. Then close parentheses and then continue. Actually, no, this is the end of my code. So I'm going to select everything and run again. So now I'm just going to visualize them just by saying data viz. So I'm just running this code. A variable not found. So maybe I did a problem somewhere. Variable. Let's see. Variable value. Maybe I just made a little mistake. Let me solve this problem very quick. Of course, with everything, it is just a very small and silly typo. Of course, it has to be variable. I wrote variable, so I have to add a. So variable value. Okay, now it should do well. Okay, now let's look at data viz. Okay, now I have managed to produce the graph. So this shows the highest temperature and the lowest temperature for Phoenix, Arizona for different parts of the year, and then the yearly high and the yearly low in record high Fahrenheit, record low Fahrenheit as well. Now, how you extracted this data is by scraping. You went to Wikipedia, you scraped this individual table, and then you cleaned and formatted this data so that ggplot can understand what data you're working with, and then visualize this. Now, all in all, this is simple. It looks very complex at first, but it's just 35 lines of code. It's very simple. Now, I'm going to assign you another really nice video on scraping. Please do that apart from this video. And at home by yourself, try to find another city. It can be an American city, it can be a European city, and try to find this climate data for the city that you chose as well, and produce a similar graph for the city. It can be Paris, it can be London, it can be Istanbul, it can be any other city that you want that has this table, record high, record low. Let's see if you have a functioning code by only changing very little line of code, because this is already a functioning code. Let's see if you can very briefly change this code and create another graph like this for another city of your choice. So let's see if you can do this. Please let me know if you have any questions and problems. So good luck.